we'll review these spirals and then we've got to move on. Anybody remember what the difference is between these two spirals, Philip?
The left one's the Archimedean spiral, so it spirals out, and the right one is hyperbolic.
Exactly. So this one's called Archimedean, and like he said, it's going to start at the pole. When we graph it, it's going to start at the pole and spin out. This one is hyperbolic, which means it's going to start out here somewhere and spin in, right? So, okay, so the parameters on the notes, my range for theta was 0 to 12 pi. Now, why did I pick 12 pi? Well, what is 12 pi going to do for me? 6 revolutions, right? Which will give me a nice little spiral. If you want it to go more, then you're going to have to increase that number, right? Now, let's think about our x's and y's. First of all, we're in radians. So your quiz, you hopefully were in degrees. Let's go back to radians. And the theta, the biggest theta can get is 12 pi. Pi is 3, approximately 3. So what's 12 times 3 is 36. So the biggest theta is going to get is 36 approximately. So 3 times 36, I don't know, I'm going to set my x's and y's at like 120. Would that take care of it? So negative 120 and 120. And let's see if we see what we need to see. So x min, negative 120, positive 120, negative 120, positive 120. And I am graphing 3 theta. Getting a nice little Archimedean spiral. Beautiful. And it spins and spins, and then all of a sudden it stops because it's gone around 6 times, and that's what you told it to do. All right, let's come over here and talk about this one. Now, obviously, we need a window adjustment here. Right? So let's talk about, I mean the theta the same, of course, but now let's see what might be good. They need to be small. Yeah. What do you think? I use for my x-min and max, I use 0.2, negative 0.2, and positive 0.2, and that gives me a decent picture. This one, depending on how you have your window set, you might not see the very beginning of it, right, because it's spinning in from the outside, but eventually it should come in the screen and you should see it. And like the other one, it's going to spin a while and then it's going to stop, because you told it to go around 6 times. All right, those are our spirals. Good deal. What are the other 3 classical curves? Quick review. The lemniscate. Yep, and what shape is the lemniscate? Figure 8. Yep. What else do we have? What do we have? We have the limacon, which is like a lima bean. And we talked about it can have an interior loop in it. It can have a very strong indentation, making it a heart shape. Or it can just kind of be slightly indented or relatively flat on one side. And all of that depends on the numbers in the problem, right? All right, so we said lemniscate and limacon. What's the other one? Rose. Yep, it's a rose. Okay. Now, the next question says, without a calculator, describe this thing. Now this, all of our quizzes should be turned in now. This requires, you to know something that was on the colored sheet. So if you have your colored sheet, dig it out and see if there's anything on it. Is there anything on that colored sheet that looks at all, it's not gonna look exactly, I promise, but is there anything that looks at all like this? David?
Sine 2 theta.
Okay, so the formula for sine 2 theta is 2 sine cosine, right? If I factored a 3 out of what's on my notes, I would have a 2 cosine sine. Would you agree with that? I can pull that 3 out. So now I have this. Now, if 2 sine cosine is the sine of 2 theta, what do you think 2 cosine 2 theta sine 2 theta is? This is the sine of twice 2 theta, isn't it? If this is the sine of 2 times theta, then isn't this the sine of 2 times 2 theta? So that's the sine of 4 theta. There's a 3 out in front of it. So another way of writing the equation is like that. Well, what is that? We're not graphing it, we're describing it, Robert. It's a rose. What can you tell me about this rose? How long are its leaves or its petals? 3. How many of them are there? 8. Okay? Now, I want you to graph the original equation on your calculator. You're gonna have to change your window. We're going from 0 to 2 pi. The only one that you're gonna mess with that theta is the spiral. Otherwise, leave it at 0 to 2 pi. And you told me the leaves on this thing are 3 long. So let's have our x's and y's be -5 and 5. That'll cover it. 10 would also cover it, but it would kind of make it small. And I'm graphing the original. I'm graphing what was in the notes. So 6 cosine 2 theta, don't forget to close the parentheses, sine 2 theta. And do you get what we said we were going to get? Yes. You get a nice little rose. These leaves are 3 leaves. And those are okay, kind of a tricky problem. All right, number 8. Without graphing, we're going to graph in a minute, but without graphing, just in general terms, what's going to be the difference between these 2 equations in problem number 8, just in general? First of all, what shape are they? They're limacons, right? They're limacons. And since it's 2 and 2, they're actually going to be cardioids, right? So they're going to be hearts. What's going to be the difference between these 2 hearts? Where the indentation is, right? Whether the indentation is top, bottom, left, or right. Okay, graph them and see if that pans out. You can leave your window the same. See if that's what happens. See if you get a couple of hearts and they're dented in on opposite sides. They should be exactly the same size. Did it happen? Yep. So now we're going to prove r equals 3 minus 3 sine theta. Now, I'm not going to make you memorize the tests of symmetry and polar coordinates. You're supposed to know them already in rectangular coordinates. We talked about that back in chapter 1 or 2 or something. But in polar coordinates, if I want you to do this ever, I will give you the test of symmetry. But we're going to prove that r equal, or this equation, is symmetric about the y-axis. So what you do is, you replace your variables, just like you do in rectangular coordinates when you do tests of symmetry. Change the sign on x, change the sign on y, change the sign on both. You do exactly the same thing, but you're doing it with r and theta. So we're testing for the y-axis. So there's 2 tests for each. I'm just going to pick the first one. I'm going to substitute in a negative r and a negative theta. That's what it says to do for the y-axis. Does everybody see that? All right. Okay. What about this? What happens when I take the sine of a negative angle, David?
Doesn't it just go on the outside?
It does. So this is actually going to become 3 plus 3 sine theta, because sine and cosecant and tangent and cotangent are what we call odd functions. When you change the sign on their input, you change the sign on the output. Agree? Okay, so now I have the equation I like to have r by itself, negative 3 minus 3 sine theta. That doesn't look quite exactly the same, does it? Let's try the other test, the other one. It says, go back to the original equation, don't do anything to r, but change your theta to pi minus theta. Okay, what about this? Uh-oh, good thing we have our colored sheets out. Because what's that? I'm going to do it over here to the side. That's sine of the first, cosine of the second, minus sine of the second, cosine of the first. Remember, that's those UV things on your colored sheet. What's the sine of pi? Pi. Sine?
Oh, 0.
0. Sine of pi is 0, right? So this basically is gone because it's 0 times cosine. It is gone. What's the cosine of pi? Negative 1. So this is negative sine times negative 1, which is basically positive sine. Right? So this came out to be positive sine, so my equation is that the same as I started with? Yep. So, you know how there's more than one way to name polar coordinates? You know, every polar coordinate can be named more than one way. So there's multiple ways of doing almost everything. And you just keep trying them until you find one that works. Now, there's only 2 tests of symmetry. So if this hadn't worked, then it wouldn't have symmetry about the y-axis. But I have to try both of them. Okay? All right.
So he's actually the one that doesn't work.
Yeah. Yeah. Well, the thing is, Ben, if you, oh, never mind, I'm not gonna confuse the issue. Yes, try both of them. If neither one works, then you don't have symmetry. But if either one works, you do have symmetry. Okay, you'll see in the definitions there, it says this or this. So you're testing to see if one or the other works. All right, so now we're gonna do another one, and we're gonna test for all three. Okay, so let's see if we can get through this, because we have one more thing to do. We can get through this real quick. What's our equation? R equals 3 sine 4 theta. All right, so let's do x-axis first. All right, so x-axis, I'm going to substitute in negative theta. So R equals 3 sine negative 4 theta. Is that going to give me the same equation? I don't think so, guys, because isn't sine odd? So what happens to that negative? It comes out in front. Now, if this were a cosine, I'd be all good, right? Because in a cosine, this negative drops out. But in a sine, it has to come out in front. All right, so I need to try the other one. The other test says negative R equals 3 sine 4 pi minus theta. Now you gotta be careful with that 4 in there because you're replacing the theta with whatever it is, in this case pi minus theta. Okay? So now we've got negative R equals 3 sine 4 pi minus 4 theta. Okay, here we go. We got to figure out what that is. Sine 4 pi minus 4 theta. Good thing you have your colored sheet. Here we go. That's your U and V. So sine of the first, cosine of the second, minus cosine of the first, sine of the second. Now don't be confused by the 4 pi. Where's 4 pi on the unit circle? Where's 4 pi? Same place as 0, right? So basically we're saying, what's the sine of 0? The sine of 0 is 0. So that's like gone. What's the cosine of 0? 1. So this is like negative sine 4 theta. Would you agree with that? So plugging back in, I have negative R equals 3 sine negative 4 theta. Oh, excuse me. That's not what I have. It's negative sine 4 theta. 3 times negative sine 4 theta. Isn't that negative 3 sine 4 theta? And the negatives cancel. Do I have symmetry about the x-axis? I do. Awesome. Now I get to do it again for the y-axis. Here's my original. For the y-axis, alright, I can put in negative R and negative theta. Ooh, I think this one's gonna work, do you? Because negative R equals negative 3 sine 4 theta. Remember, it's odd, so that negative's gonna come out in front. Is that gonna give me the same as the original? Yes, good, that one was easy. All right, and now we have the origin. Okay, this isn't gonna work. would you agree I'm doing the origin now? And I plugged in negative R and left theta alone, and that is not going to be the same as the original. So I'm going to do the other one, which says leave R alone, and then plug in theta plus pi. Is everybody keeping up?
Yep.
All right, so here we go. I got to do that. Sine 4 theta plus 4 pi. Off my colored sheet, sine of the first, cosine of the second, plus cosine of the first, sine of the second. So again, where's 4 pi?
0.
Yep. So the cosine of 4 pi is, so this is sine 4 theta. But the sine of 4 pi is 0, so that's 0. 0 times anything is 0. So all this right here boiled down to just sine 4 theta, and lo and behold, they match. So we have symmetry to everything. Right? All right, that homework is going to be due on Tuesday when we come back. What I need you